when you blow the shofar, what are you signifying?
When I sound the shofar, it has four distinctive calls. One is called tekiah.
Tekiah.
The other is severim.
Severim.
Teruah.
Teruah.
And tekiah gordola.
And tekiah gordola.
Yes.
Okay, and what language are you speaking when you say these words?
That is...
Is this Hebrew?
Hebrew.
Okay.
Yes.
Here it goes.
So tekiah.
So now I want to make a model of this, and I'm going to measure it. I'm going to take my little tape measure, and as you can see, if I start here,
yes,
there is like 1, 2 curls. If this is about 3 feet, then the pitch is like half 3 feet. Right? Then if I were to take a cross section here, I would get like a teardrop. You see that?
Yes.
And the teardrop, this kind of sharpened section, is following this all the way around, and it follows the helical nature of this thing.
Yes.
So those are the measurements I have. I need 36 inches. I need an 18-inch pitch. I need the diameter here, which if this is a cone, this is like conical. So my diameter here is about 10 inches, and over here, it's maybe 2. So it goes from 10 to 2 with a pitch, and the rest we know. And then this, the actual teardrop shape is, I'm going to call that 3.5 inches with a 2-inch diameter.
This is exciting.
Okay, so now I'm going to make the CAD model.
Okay. That's exciting.
All right.
That's really
very
exciting.
nice. All right. So what I'm going to do now is create the main variables that I'm going to use to create this model. And it's very, very nice to have a hand sketch. It's very nice to have some forethought as to what you're building, what the main dimensions are going to be. And so then when you build the model as per those dimensions, you can change those dimensions so very quickly, because NX has an awesome way to do that in the expressions editor and such. And then you can really get the model to be perfect. So what we know is if I draw a center line on this piece of paper, we know that the shofar is basically conical. So what we're going to have is a D1 and a D2. D1 and D2. We have an overall length, which we measured to be about 36 inches. So I'm going to say L equals 36. What we saw was that there were basically 2 loops within that cone, and I'm going to represent that with the variable n. N equals 2, so there's 2 loops. We saw that the basic cross section was something that looked like this. It had kind of a, let's say, pointy section. Its overall length, I'm going to call this L2. I'll call this L1. L1 and L2. So L2 was equal to 3.25 thereabouts, and then the width of this, I'm going to call that W. That was 2 inches. Okay, these are all inches except for this one. This is a unitless number. D2 was 10 inches. That was a diameter, so there's 10 inches there. D1 was about 1 inch. It's 1 inch there. And so now we have almost everything. We just need one more measurement, and that is the fact that the shofar basically started off as almost a circle. And so we're going to have that circle be, I'm going to call it, I'm going to say that this is going to be D3. D3. and that's going to be equal to about 1 inch, D3. And then finally, the diameter of this circle right here is 0.5, and I'm going to call that D4. So now when I create this shofar, I've got all the variables. I probably should give it a THK of 0.125. So THK equals 0.125. So I will be shelling this thing out. And those are all the variables that can drive this. And like I said before, once I have this built, I can change the number of coils. I can change the overall length, this diameter, the starting diameter, and make sure that we can iterate very quickly to make this thing work out. This is going to be fun. And now it's time to make the first little portion of this, which is the helix that drives everything. So, let's see, I like to drive the helix along a line. So I'm going to put a sketch on here on the XY plane. And that's going to be nothing more than a line. Put right here. And that's going to be a line of length L1. So there's your L1. It says variable does not exist, so I must have messed it up. So let me see. Double click on here. Let's do the formula. It's this one here. Say okay. There it goes. Okay, so I've got this little line segment, and that's going to be the basis upon which I establish the helix, and I'll finish that off like that. Now the helix command is very nice, and the helix command has a long spine, so I'm going to select the line segment as a spine, and it's got a radius or a diameter option, and the diameter can be varied as you go along, and so I'm going to have a linear variation, and the start value will be D1, and the end value will be D2. So that's that. Then the pitch is the length divided by N, so I'll just say LL divided by N. That's the pitch. And the number of turns is N. So put N there. And so as you can see, I've got the basic shape of the shofar. I've got 2 turns, and it's conical, if you will. Just for giggles, I'm going to go back to that original sketch. And I'm just going to make a little demonstration, if you will. I'm going to make this conical kind of indicator, if you will, where this dimension right here is D1, and this is D2. Let's just do kind of a sanity check here. And I'm going to make midpoint. So this point right here is going to be on the middle of there. This point right here is going to be on the middle of there. And I'm going to use point on curve such that this point is there. And that point is there. And what I've just done should encompass the helix, and it does. And all of this is just a verification that the helix is following what we wanted it to do. Okay, so those are all reference lines. So you can see the helix goes along in the right shape, the correct shape. And that is very powerful. Okay, so the very next thing is to create a cross-section on the end of the helix that will emulate the little shape. Let's see, where is it? Right there. This little shape. Oop, that one, right there. And in order to do that, we go to the sketcher and we say on path, and we select the path, and we push the coordinate system that's created to the very end of the path, and we sketch the section. And the section looks like, I'm going to do it in the profile tool, it looks like a line, an arc, a line, and an arc. That's what it looks like. And I'm going to put the constraints on it. For example, we need, let's see, a tangency here. We've got a tangency. Okay, and I want to do a vertical alignment between there and there. Vertical alignment between there and there. I want to put a dimension on here from there to there, and that dimension happens to be L2. So put that on there, and then I want to center it, and so I'm just going to easily put L2 divided by 2, like that. And there's a definite diameter right here, just the bottom, and the bottom is D4, like that. And then we have a diameter here of W. There we go. So that's what the shape looks like. That's going to be swept along this guide. Now, when I looked at the Shofar, the actual Shofar, the section was rounder than this. So either I've got to make L2 shorter or the width larger, and all the dimensions that I have put in should show up in the expressions list, user expressions. So I'm going to go for W, and I'm going to make W 2.5 instead of just 2. And that's more like what I saw on the actual piece of geometry. Cool. Okay. The next thing I'm going to do is make another section at the bottom of this thing so that I can sweep from section to section with this as a guide. But I've got to know the orientation upon which this section will rest. And so I'm going to do basically a trial sweep. So I'm going to do a swept. I'm going to select this is the section. I'm going to select this is the guide string. And I'm going to just say fixed here. And this is doing what it's supposed to. And as you can see, the final section is oriented in such a way that the smaller portion right here is parallel to the y-axis. So that's good. So now that I know that, I know how to create the next section that I will place on this swept feature. I know its orientation, if you will. So I'm going to hit cancel. And I'm going to make another section right here at this end. And I'm going to make sure that the shape of it is oriented in such a way that the small portion is on the left-hand side. So I'm going to go into the sketcher. I'm going to sketch on path. I'm going to select this as the path. I'm going to pull this out like this. And I would like the X to point this way and the Z to point at my nose. I'm double-clicking on the Z. and I'm going to say select horizontal reference, and I'm going to make it parallel to the Y, basically, and say OK. There. And so now I know my section has to be oriented, like so. Like that. Like that. Okay. So now I've got to fix that up. I've got to have tangencies right there, a tangency right there. I want a horizontal alignment between those two, I want the diameter D3. I want this to be D3. This diameter here. D3, it's small. And I'd like a dimension. I'm going to put a dimension between the center of the drive curve and the center of this this diameter to be D3/4. That's too much. It's D3/8, let's say. There we go. And I would like the dimension from here to there to be D3 times 120%. That's 1.2 times D3. There we go. And I'll make sure that the diameter of this thing is always half of D3. And that is a very nice way to conclude. You know, I'm sweeping from one section to the other. That's a nice way to conclude it. And say close. So now I have all the construction geometry I need to make this thing work. And I need to go to the swept function. Swept function. My first section. Incidentally, when I select these sections, I've got to make sure I select them in a way where the entities coincide with each other or correspond to each other. So swept. So what I'm going to do is each time I'm going to select the section right near where the big more bulbous curve connects to the line segment. So I'm going to select right there, and it's going to force the mapping to go in this clockwise fashion. Good, and then I'm going to hit the add new section button, and this time I'm going to click right here, a corresponding location. Then I click the drive curve, which is that, and I'm going to do fixed. I'm going to do preserve shape. Turn that on. And say OK. And that is looking pretty good. Let's see, maybe I spoke too soon. Hold on. Let's see. There's something not so good happening right there. The shape is twisting in a way that is not healthy. And I'm pretty sure it's because of the rotation of this section. And in order to try to fix it, well, you know, the best way probably is to use one section and then put a scaling factor on it. That's probably a superior way. And I should probably use the perimeter law method. So the perimeter law method requires the definition of this overall chord length, if you will, of each section to be placed in the operator. So I have to know what the arc length is of these two. So let's delete the swept, it's not working. And let's find out what perimeter 1 is and perimeter 2. So in order to do that, we need to do analysis measure, and we need to do a curve distance, and we need to do object set, and we need to do tangent curves, and we need to select right there. And as you can see, the length is 8.8. Good. And then I'm going to delete this, 8.8. And then I'm going to go down here and do it again. 3.4. 8.8, 3.4. Okay. So now we can finish this up by saying surface, swept. We're going to select one section, and we're going to sweep along a guide. All right. And we're going to have a perimeter law for our scaling method. A perimeter law. And we're going to have a linear law, so it's going to take two values, and we've got 8.8 and 3.4. So with 8.8, you can see that the law stays very, very, very close to the actual section. And this one too, only it's just rotated just a slight bit, and that's to be expected. So 8.8 to 3.4. So there is a very good exterior shape for the Shofar. And I have preserved shape on so that I'm getting actual face segments where I want them to. It's okay. And then the final operation that we need is the shell command, and that is shell. The shell thickness is THK. So, and I want open, and I want to select this face here, and this face here, and say okay. And that is pretty much a finished product. That's pretty cool, isn't it? Let's clean it up a little in terms of its look. Control W. I'm going to get rid of the coordinate systems and the curves and the sketches. And I'm simply going to go to my view, and I'll do the style, true shading editor. It's nice. The coordinate system is showing, and I'll hit the W command and get rid of that. So that is what the Shofar looks like. You've seen it demonstrated. Of course, there's a little mouthpiece here, but we'll neglect that. So there's your basic shape. Pretty cool, huh? And now, with all these dimensions, I can easily start changing things, like maybe it's just a little bit too curvy. Maybe I want it to, be a little straighter. So that means D2 can be reduced to, let's say, 7. And then there, straighten it out a little bit. Maybe there's too many curls or not enough. So I'm going to go to N, and I'm going to make N 1.5 instead, so that I'll straighten it out. And then I'll also try N equals 3, just for the fun of it. N equals 3. So it's very, very nice that I can so quickly make these changes. And, it appears to me that this shape is a little bit too tight, if you will. So W is not big enough. So I'm going to make W3 instead. And see, so there is a very, very nice way to make very rapid changes because I took the time to make the expressions first. And as you can imagine, this is a labor of love. So my name is Steve Samuel from Design Visionaries. I love doing this kind of work and I love the feedback. So these techniques are very, very powerful, and as you can see, they're very easy. Once you know them and understand them, you can design and build and almost anything that you can think of. So please like and subscribe this video if you can, and share it with others. Come back to the website when you're modeling and you have some pretty interesting but difficult piece of geometry that you're having trouble with, and make comments on this thing, and I use the comments to figure out what my next video will be on. So please interact and have a wonderful, wonderful time modeling. Thank you very much.